All right, welcome everybody. Thank you for joining us today for our ProTechTalk. This is a really exciting one that we are pleased to have our original panel back together. This was something we started at the Frac conference back in February of 2020. We've done 10 of these ProTechTalks now and are circling back around to where we started. Kind of reflect back, see what we've learned the past year. A lot has changed from what we thought when we did this in February 2020. So we're really pleased to have everybody back and have everyone joining us today. If you missed any of the past talks, I'll put a link in the chat. So everything's posted on YouTube and on the ProTechnics website. So you can go there to view those. And thank you everyone for the questions submitted along with registration. We've worked a few of those into the discussion for today. And if anything comes up as we're talking and there's new questions kind of come to mind, feel free to throw those in the Q&A. We'll try to get to them today. If we can't during the discussion, we'll definitely try to look at those and follow up afterwards. So I'm going to drop off from video. I'll be here in the background. We do have a couple poll questions we're going to do. So every once in a while, I'll jump in, buddy, and let you know, hey, time for a poll question. We'll put those up. The panel can have a chance to vote, but also get a little discussion going. And then we'll look at the results before we move on. So with that, I'll kick it over to you, buddy. Thanks.
Okay, well, welcome, folks. It's great to have everyone on here for our 10th in the series of ProTechTalks. And we're really very excited about the topic today and the participants, our esteemed panel that we had for the original ProTechTalk. And so we welcome you, the attendees. Hopefully this will be a very informative, very interesting discussion time together. And we welcome your input. You can certainly add any comments that you might have in the chat, and we'll try to get those questions addressed to the panelists as we go. And please participate in the questions, because we want you to take advantage of this opportunity you have to pick the brains of the industry's best. So take advantage of this opportunity and help us with the poll questions. And this will be a very informative, very worthwhile endeavor for all of us. We're excited about it. Now I'd like to introduce the esteemed panelists that we have. Again, this is a second tour of duty for these individuals in doing ProTechTalk with us. And we're very excited to have them all here with us. First of all, I'll introduce Paul Weddle. Paul is the Vice President of Completions at Taprock Resources. He joined Taprock in October of 2020 as the completions manager and has since been promoted to the current role of Vice President of Completions in March of this year. Prior to Taprock, Paul was the Vice President of Drilling and Completions at Liberty Resources. Prior to Liberty, Paul held engineering roles in completions, production, asset development, and technical leadership for new field exploration. He began his career with Shell as a completions engineer and a location supervisor. He received a Bachelor of Science degree in petroleum engineering and graduated with honors. I'm not going to mention his institution because we're going to have our little contest. Okay, all right, we see that, thank you. We're going to have our little contest where we will describe the individuals, tell you what kind of degree they had. Now that Paul's already blown my cover here, and we're going to tell you what their favorite hangout was in college and see if you can associate that description with the individual and thus his alma mater. So that'll be fun. If you think you have figured out who goes where, please send your list of those combinations through the chat line, and we'll announce a winner towards the end of the ProTechTalk today. Next up is Lucas Bazan, our next panelist. He specializes in hydraulic and acid fracture design and fractured well performance evaluation. He established Bazan Consulting in 2008 after working with ConocoPhillips and BP. He has authored and co-authored more than 25 technical publications focusing on hydraulic fracturing and well performance topics. In 2020, he assisted in the development. I thought this was very interesting. In the development of mathematical formulations and solution methodology for analyzing and predicting the spread and dissipation of viral diseases, including SARS-CoV-2. So he's a multi-talented individual, not just an oil industry individual. He holds degrees in physics from the only university attended by a U.S. president. Wonder how many of you know the answer to that question. Now I've blown that cover too, come to think of it. All right, well, I haven't told you what it is, so you'll have to figure that out still. And he has also a petroleum engineering degree from a different university. His favorite hangout in college was an interesting one too. So again, we'll see how this goes. I don't think I even told you what Paul's favorite hangout was, so I need to backtrack. Paul Weddle's favorite hangout in college was an institution known as Posse East. Okay, so he's blown the cover on that, so probably pretty well figured out the particulars on Paul. Lucas, on the other hand, his favorite hangout was the Petroleum Lounge at his institution, where he enjoyed playing 42. So there you go there. Next up is George King. George started working at Amoco Research in 1971. He has 50 years of experience and over 100 technical papers that cover a wide spread of engineering projects. He has a BS in chemistry from his institution and a BS and MS degree from another institution in the same state. His favorite work areas that he describes are the weird and unusual new technologies that pop up as the industry advances. There you go. That sounds like George, all right. And his favorite hangout in college was any garage with sports cars. That's not going to help you much with his college, but there you go. So next up is one of our own, Dick Leonard. Dick has a petroleum degree from his institution. He started with Pennzoil in Corpus Christi and later joined Champlin, which became UPRC. He, interestingly enough, he worked with Nathan Meehan at UPRC during the infancy of water fracs in the Cotton Valley and the famous "We don't need no stinking proppants." He's been with ProTechnics now for 20 years. He's currently the Director of Engineering Diagnostics at ProTechnics Division of Core Lab. So his favorite hangout at his institution was a famous beer garden. In fact, it is the oldest continuously existing business entity in the state of Texas. So I'll give you a little bit more of a hint on that one. Okay, well, welcome, gentlemen. Thanks again for spending the time with us. And let's jump into these questions and let's start picking the brains of the brightest and the best here. Okay, question number one. How has your view, if it has, let's just say, has your view of how to emerge from a downturn changed through all of this lately? If so, in what way has your view of handling a downturn and how to emerge from it changed based on this most recent downturn? So who wants to kind of tell us how you view this dilemma going forward? All right, George. You waved a hand. I didn't know whether you were raising it or just waving it.
Well, I was just going to scratch my nose, but I'll go ahead with this one.
Okay.
Basically, I've seen probably 7 downturns in the 50 years that I've been in the business. And some of them serious and long-lived, some of them serious and short-lived. The seriousness of it depends on whether you're affected or not. And the issue around the companies that survive these things, and I've seen it time after time, is you're careful with your spending, but you keep spending on the things that have to be done, the collection of data, the maintenance that is necessary to keep a well going. And those are just two of the illustrations I give there. But use your head in terms of picking and holding on to good property. And sometimes it's not the new technology we try, it's the old technology that we successfully apply to what we're doing. So it takes work, it takes patience, and it takes a little bit of luck. That's all for me.
Okay. Who's next? Who wants to address this business of a downturn and how you might handle it in the future?
Yeah, but I guess for me, the way the question was framed, I don't know that my view of how to emerge from it has changed. I think it's very much what George said. I would echo that. We do the things, we work on the things we can control, try to ignore the things that we can't, and focus on what makes the most business sense. Certainly there is, in my 25 years, there's been various attacks on our industry throughout then. This one looks a little different from an administration standpoint. And then the amount of debt that I see us taking on as a country, that has shaped my view a little bit, slightly more pessimistic, but I still feel that sticking to the fundamentals will carry us through because the product is wanted and needed. But I think those that survive will stick to the fundamentals, their fundamentals.
Thank you, Lucas. Dick?
I think and I agree with both George and Lucas. I think probably the difference of this downturn is obviously there's more emphasis on cash flow, making sure everybody's making the right decisions. So I think it's all about, doing things in the best possible way. So I think, optimizing our completions, historically we've been known to, bigger's always better, the bigger hammer wins. But I think we're going to see a lot more on just truly optimizing the completions. And then the other big thing is leveraging the immense amount of data we now have and using it in that optimization process.
So Paul, now that you've been through another downturn, how do you view operating philosophies and development strategies going forward now that you're part of a startup? Are you going to approach those a little differently?
Yeah, I mean, I think I've been through a handful of these, right? And I've been at companies where I was working the asset that was the only profitable asset in a crash. And so we got more money and got really busy. And I've been at assets and companies that have pretty much rolled up. They're drying out their entire budget. And I think what you find is always when you really push on cost synergies and doing things with the right number of people and not being overstaffed, it's amazing when you actually work that tail end of LOE, the stuff that maybe doesn't get as much attention as when you're spending, millions of dollars. It's amazing what you can find. And it's always, for me, it's why didn't we do that when times were good? And the companies that tend to have the most resiliency to come out. And some of that comes with having a really good, forecast of your wells and your production and not lying to yourself on EURs so that, your production is what it's going to be and you're working the right things to just give yourself as much resiliency in the system as possible, which means not being overextended when times are good and hedging if you are putting massive capital investments into the ground so that you have flexibility when things do hit. And you can, make strategic decisions and not have the bankers force your hands, right? And I've kind of lived through both sides of that. And I'm at a shop now that was able to monetize a lot of hedges, and we're busier than we've ever been. So, but you got to have tier one rock to be in that boat too. So that's where the little bit of luck comes into play, or give credit to the geologist. But I think this is a panel of engineers, so we don't have to do that.
So we're only as good as our rocks, basically, huh?
the end of the day, that's what drives the business, right? There's only so much you can do. You know, quality assets and not kidding yourself on what you have is absolutely vital to surviving downturns and coming out stronger on the other side.
Good summation. George, you think we should be more focused going forward on production enhancement or cost efficiencies?
I think you're going to have to do both. And as has been mentioned here several times, yes, you have to have good rock, good things to produce from, but also as you look at this, and this is particularly true in the shales formations and the lower permeability reservoirs, there is a wide variance of both permeability, porosity, and mineral content in these shales along a single wellbore. And if you really use a lot of tracers, like I've always suggested here, and yeah, Dick, you owe me a beer for that one. If you use those things correctly, you can tell where your production is coming from, but you have to keep measuring over a year sometimes to get this background data. But what you'll find is that 80% of your production is coming from between 30 and 50% of your wells. That means we're putting a lot of wells, a lot of frac stages in these wells that really don't pay off. And if you're looking at $100,000 per frac stage, you can save $1 million on a well real quickly if you can understand where to complete and frac. For that, we're going to need to know a lot more about our reservoirs. And so you don't pass the baton to the geologist, you work with them.
Well done. How about you other two? Production enhancement, cost efficiencies? What's the balance there?
It's a numerator and denominator. So I agree. You got to work both. You know, I think you just have to prioritize based on where your biggest margin barrels are to keep those protected, and then work your way down, just kind of the Pareto principle, focusing the effort in the right spot, and, you know, different people at different pieces of the value chain, not playing little kid soccer, is a really good way to run a lean asset and maximize your margin.
Yeah, and I agree. I mean, I think production enhancement, I really look at it as just overall maximizing the net present value from these properties. And that might not be the maximum amount of production you need. It's all of it rolls into it. So it's a combination of the two.
Yeah, I would pick up on what Dick would said. I think it is a value solution. I mean, certainly we have to have the cost efficiencies, and as George said, certain wells, maybe we can digest a little bit more cost than others, and understanding which wells those are, where they're in the field, maybe which stages they are, I think will help with that.
Great. So here we are. We're trying to balance production enhancement with cost efficiencies. We know that we're a little capital constrained at the moment. So how do we stretch the technology environment in this situation we're in, this environment? How do we make the most we can in the technology arena with our constrained CapEx? So you all stumped on that one. There you go, Paul.
No, I'll take a quick stab at that. I mean, we just went through a science budget for the year. And what you end up finding is where you have the overlap between the most disciplines that get excited about the same kind of diagnostic projects, because they can all learn something and all, you know, push to the next level and answer that question about what's next. You get a lot more synergies and working together as a team when the whole team's excited about a project and it's not, you know, the driller's pet project or the completion team's pet project. So I tend to think that, again, prioritizing on what benefits the most when it comes to those diagnostics, and who could learn the most and impact the big decisions, from well spacing to, you know, which benches are going to work. The true needle movers on the value, not chasing pet projects, is a really good way to focus.
Yeah, for my part, certainly we need to spend money on technology. What I often see and help clients with, though, is what does success look like from a technology? We often spend dollars on a technology thinking that a result, it means something that it may not, or that success is only a small range of parameters. And I don't think that's the best use of a technology. I think that we have to be honest on what is it that we're trying to do. What does success or failure look like? There's learnings from both of those. And as Paul mentioned, what's the value for it, and does it move the needle on not only this well or this audit, but forward modeling, right? How are you going to apply that in your development?
Yeah, and I'll echo that. I mean, I think a key piece in having been doing this side of the business now for 20 years, you know, we've seen a major shift in how people look at technologies, you know, specific to our world and the diagnostic world, you know, and I think it's all about how do you get the most bang for your buck on with a diagnostic dollar. You know, in the past we used to, you know, trace every stage of, you know, a long lateral. And the reality is, I think we've figured out ways that we can get almost as much value, but maybe do it for half the cost by tracing fewer stages and spreading out those diagnostic dollars to answer more of the questions. I think a lot more involvement in the planning stage now, I know, whether it's our technology or others. And I also think there's going to be still new technologies coming down the pipe that will answer some of the tough questions that the industry has been battling for years.
Great. I think it's about time for our first poll question.
Yep, this one here should sort of tail in nicely. So let me go ahead, hit launch. And everybody can vote, and then we'll look at the results in a second. We'll give everyone a few minutes, but while we're doing that, buddy, if we want to have some discussion with the panelists, you guys can vote as well, but if we want to kind of talk through it a little bit, we can do that for a second, and then we'll look at the results.
Yeah. Would one of you gentlemen like to sort of debate some of the
Buddy,
votes here?
I'll just start out with a comment. I think the one thing that's obviously, and I mentioned it earlier, the big opportunity out there is with regards to data analytics. You know, what can we do with all of the data that we've already got in hand? And I think through the years, I think a lot of the diagnostic data and other data gets, you know, used in only a minimal form. Maybe it helps you make a decision right away, and then is put away for the long term. And I think leveraging that in the long way, looking for trends over basins and things like that, I think that's a key to our success coming out of this downturn.
I'm going to put in a point on that one, if you don't mind.
Sure.
Data analytics is a fabulously necessary deal, and my son is working in this field. However, we've had a lot of conversations between the two of us, and he says, you know, getting the right data is very, very important, but also make sure the data is an accurate reflection of what's really happening down there, because you can measure some things that are likely correlations, but they don't turn out to be causations. And so we need to apply the physics, the engineering principles that we've learned, and make sure that data is the quality stuff that we can actually make decisions on.
Good point. Anyone else? All right. Go ahead, Lucas.
Yeah, buddy. I'm sorry. Are we going to speak more later about data analytics and that?
Yes, we are.
Okay, I'll hold my comments for that then.
In fact, we're going to talk about that pretty darn soon. Do you want to announce the results of that first poll?
Yep, coming in just 1 second.
Okay.
Here you go.
Optimizing spacing. By a pretty wide margin too. Very interesting. Okay, well, why don't we just go ahead and jump to the data analytics question. What do you see as some of the most promising developments in data analytics at the present time? Lucas, you want to start us off there?
Yeah, buddy, I guess concerning that, I certainly am a proponent of using existing data. We as an industry collect tens of thousands of stages a year, millions of data points, and we haven't done the best job of doing that. So I certainly I'm all for these data analytics. I think that they're really valuable tools. But what I see exciting about data analytics is that I hope we start using them less, because and I say that as I review, I'm on these committees for these conferences, I'm seeing more and more abstracts coming in where the people are working on trying to ground truth these data analytics or apply the physics solutions to what these data analytics are showing. And I do think that was missing early on. I think it's diluting the talent pool of young engineers. I think it removes some of the foundational learnings that as petroleum engineers, as petroleum geologists or technicians, that we need to understand these data and the interrelationships, what George was saying. So certainly getting very clever where we do machine learning, neural network training and all that, that's all fine, right? But really, my position on it is we should use the data, but you have to have, I think, expertise to understand the data, because and I see that the trend I have seen is that being diluted, and that young engineers that have degrees in petroleum studies or geologists, they move to become data scientists or Python programmers. From a career perspective, excellent. I mean, that makes sense. But from an industry advancement standpoint, that is not the way to use the data, because we need expertise to marry with that data, not simply better dashboards.
About it.
Yeah.
Go ahead.
I'll go on top of that is, I've always found that if you lean too much on data analytics as a silver bullet, you do stop thinking about kind of first principles in physics and what matters. And you limit yourself to what the machine knows and kind of give it too much credit sometimes. I think it's always useful, point you to what might matter, but you always got to go deeper, because all of those data analytics are limited, their analysis, to the resolution of the data, right? So for years and years in most basins, people talk chase stage length and just ignored, well, what were they doing on a cluster? How many clusters were they shooting? What was their perforating strategy? What was the rate tied to? And I think most people now realize that, effective cluster count and density is far more important than just a broad stage density. And that's just one example. And so I just always encourage people, if the data says it means something, ask why, learn the physics, and say, all right, let's go outside the box and really push it and find where it stops being accretive, right? Where the diminishing returns are. And you usually don't find that within the data set. So just don't constrain yourself to the data set. It might help you ask better questions, but that's about it.
I think those are great points, and I think is often, lacking, is that we, and when I said it's a critical piece, I think you do need to have the knowledge behind it. And I know when I know our team, we're spending a lot of man hours trying to first and foremost make sure the data is accurate, and so we're doing a lot of QC work on it, but also applying proven engineering principles to the trends we see, and hopefully helping us make better decisions, specifically on the optimization side, whether it's, like you said, Paul, clusters, number of clusters, cluster spacing, stage spacing, all of those types of things change wildly even within its own basin. But I think there are some things that we oftentimes lose sight of by just looking one well here and one well here.
Yeah, it's often been said that sometimes we get so wrapped up in gathering information and storing up data that we lose the knack for knowledge. We don't develop the knowledge, and then we get so wrapped up in trying to be knowledgeable, we don't take the step to becoming wise. So, you know, there's a hierarchy there, and I don't think we want to get bogged down at any one of those levels. So good points all. Okay, we've talked about some philosophical issues. We've talked about some important developmental issues. We've talked about data analytics. Let's jump into some completion topics. How have your recommended perforating strategies changed during this downturn, and what's been learned since the beginning of the downturn? Are you approaching perforating from a different perspective? Not everybody at once now.
No, but
start picking one of us.
yeah, for me, no, I'm not. I mean, certainly there's a fit for purpose perforating design. There's reasons why you do what they do, all the way from Paul's extreme limited entry to pre-perforated liners, right? There's reasons for all of that, and the downturn in of itself hasn't. If maybe the extrapolation of that question is, are we pushing bigger stage lengths, fewer or more clusters? My recommendations have not changed for that personally, or for that of what I suggest for the clients, because there are things we can control and things we can't control, and I like where we're these moderate stage lengths, the larger ones. From a diagnostic or evaluation perspective, tend not to be that effective as something smaller than that. So for me, it's been fairly consistent, because there's still fundamental reasons why the fit for purpose of what they are.
And I would say the downturn probably hasn't changed much. I know when we met a year ago, the vast majority of people on the panel and even in the audience, were beginning to become believers in extreme limited entry. And obviously Paul's written several papers about it and talked quite a bit about it around the country at SPEs. I still see that moving more and more in that direction. I do think a big change, though, and it kind of touches on what Lucas said, is with a real emphasis on fiscal control. I think a lot of operators are now looking at, okay, if we've done this in 50 stages, where can we go and still get the same quality wells? Can we do it in 40 stages? And I think extreme limited entry definitely leads into that.
What about you, George? You changed your perforating strategies here of late?
Well, interestingly, I'm looking at some new technology to help align perforating with the frac direction. Also, we've been working a lot in geothermal with fiber optics for measurement of stresses, temperature, pressure, etc. And working on a project with University of Utah through the Forge project. But what we're seeing here is a need to know which direction the perforations are really going. Don't want to clip the fiber optic in these wells. Also, if you're not fully lateral, or you're some other direction here, looking again at something we looked at years ago, which was the alignment of the perforating plane with the fracture plane. And we have seen several times that this cuts down on the tortuosity around the well and can give you actually better production. So this isn't a finished or a polished type of technology yet. I know people have tracked it and tried it for years. First time I saw it was in the 80s. but it's something that I think we need to look at how the perforations are connected to the fracture, and are we making that a high capacity flow area through there, rather than putting a lot of obstructions and then kicking off things like scales and asphaltene deposits, et cetera. So there's some things there we can learn and do.
Well, we've touched on extreme limited entry completions, Paul.
Yeah, so not too much has changed in my philosophy. We've done a hell of a lot more stages with just one-shot clusters and getting the right size gun barrel so that we can actually get the right size hole. Done quite a bit of that since I've been at Tap Rock now. You know, one of the biggest benefits is when you're doing step down tests and you only have one hole per cluster, you know, holes open in that calc equals clusters open. So just the ability to diagnose what staging like rocks and different lithologies along the wellbore and how they act. We get to make a lot of on the fly decisions, you know, kind of little flow charts for our guys in the field now on how to react in a carbonate versus, you know, a lot of the other ones that treat a lot easier. And so we've just continued to refine it and try and maximize the value of that data while minimizing the time impact. And, you know, production results and everything else continue to be, you know, as expected or better, and just kind of continuing to get smarter by formation, and trying to do fit for purpose within that formation. And so really nothing's changed on my end, just continuing to push of what's available and what we can do different. And if it works, how can we do more of it? Or if it doesn't work, how do we learn and course correct as quick as possible?
What about the rest of you? How do you view extreme limited entry perforating? You know, there's a school of thought out there that as the laterals get longer, extreme limited entry might be affected. What do you think? Is that going to put a limitation on extreme limited entry, or is that going to just change the approach, the design scheme?
Well, with the pressures differentials that the single shot limited entry gives you, you're going to see a better opportunity to really break down several places. But as these laterals get longer, and we've seen this time after time, that first couple of toe stages, just the furthest you are away, you're eating up a lot of your pressure that you would normally use for fracturing in friction. And so I could see that limited entry might be more difficult to achieve at the toe stages. And particularly when you realize that first slurry that goes down there is going to clean the well up and shove everything into the trash cans that those perforations offer. And you can plug those up real easily. So, you know, we've seen failure on toe stages up in the Horn River Basin of like 27 to 30% of the time we saw failures. When we opened up one or two extra stages or extra perforating clusters in there, we saw that number drop into single digits in terms of failures. So be careful about those toe stages. You're losing the pressure due to friction pressure. You regain that as it comes back towards the heel. And I think this is another reason why the heels of these wells sometimes perform better than the toes do.
I think a key piece of this, when we start talking extreme limited entry, and Paul's case is a perfect example, you know, if you've got one hole per cluster, we need to make sure we're doing it right. And I think most everybody on this panel is a believer in uniform hole size. I think that technology, you really have to be using that type and not really going, you know, inexpensive on your perforating plan, because if you've only got one hole for each cluster, you really need to get it right.
Yeah, I'll just jump in there, right? So, you know, Delaware Basin, we'll have wellhead pressures, you know, between stages of 5,000 and 6,000 pounds on our wolf camp. So we absolutely have that pressure envelope we have to play with between pipe friction, perf friction, and just what the well's given us along with our kind of constraints at surface. And so, you know, variable cluster count down deep, right? It's always this do loop of you need a minimum rate per cluster in order to have proper transport in the pipe and maybe get the frac geometry you want. And that might limit you to how many clusters you can shoot, and then the size of the hole you need to shoot on those clusters to, again, live within your allowance on your pressure envelope. And so that's something we talk about all the time, and we will be changing it going forward. Like I said, we're kind of rolling out now a lot of our single shot. This next pad coming up will be, we'll call it 100, probably 100 odd, 75 stages, 3 different wells, all short laterals, going all in on one shot guns with our, our latest design. And from that, we'll iterate and say, hey, do we need a slightly bigger hole, or do we need to drop to 10 clusters instead of 13, or can we go to 15? And just trying to, again, keep that cluster efficiency the same for the entire wellbore is the goal. We're never going to be perfect, but yeah, absolutely. There's trade-offs, and you can't just cut and paste your stages for every formation and where you're at. So all the comments are 100% valid and stuff we should be talking about. It doesn't change limited entry, it just changes how you can apply it and how efficient you can be for how many clusters you can get in a given stage, and tell your boss that you're doing it with a straight face.
Lucas, what's your reading on?
Yeah, no,
in general.
yeah, I'm sorry, buddy, in limited entry in general?
Yeah.
No, I mean, certainly it's one of the most powerful tools in our completion toolbox for that. I mean, we do have very real pressure limitations that exist for us, and those change by often by operator, given different safety concerns or best practices. So I would certainly echo what Paul says, right? The design is often based on living within the design criteria, mass per perf, rate per perf, velocity. Some people talk about energy through it, however you want to describe it, right? There's some system that's designed and system that has to be lived within because of our implementations, right? Now, the thing about limited entry in general, extreme limited entry, these are designs of what we control, we think we control, right, on the inside of the pipe. On the outside of the pipe, we're going to make some assumptions, calculations, measurements, whatever it is, of a back stress or some type of resistance to that at the end, and our calculations often don't take those into account, even our full simulators, because they tend to be more source point type of simulators that don't necessarily change with extent. But back stress or whatever you want to call it, a common design technique is a delta P, whatever we think that might be or should be. That's based on some back stress that the formation is going to participate in, letting us know if that's correct or not, right? So small changes in back stress, 5–10% certainly can change a velocity per perforation. And the more perforations you have, the more opportunity you have for velocity changes, which means mass placement changes, right? So the extreme limited entry certainly helps remove some of those uncertainties with back stress associated with it, but we still have to make those considerations based on the rock, not only fabric, but more so stress and heterogeneity along the lateral.
All right. Derek, is it about time for another pod? Oh, go ahead, Paul.
No, I got a follow-up question for Lucas. Just practical, what do you think the best tool is, either during drilling or logging afterwards, to get that information, to take it to that level of detail, Lucas?
Well, so the best I would say is a defit, right? Now that's going to assume a point typically at the toe in these horizontal wells. So something along the way, we would then probably say some type of log or lateral diagnostic. There's many different ways we might get there with it, right? All the way from running advanced logs in the open hole to running case hole, to looking at your drilling data, rate of penetrations, weight on bit, things like that. All of those things will show lateral heterogeneity. Tying that heterogeneity to an actual stress value is where the challenge becomes, right? So it's an engineering problem that I think is solved with our engineering assumptions and our best practices. But I think from certainly your cases, Paul, I would think it's probably much easier to decouple that because you've got one perforation or a number of perforations, right? To try to back into that number to see. But, there are, these simulators, of course, that do that, where you can change all of that. What does that mean in the field? It's a little bit harder to narrow that down, but in a lot of ways, what we do, we're fortunate because we're not really dealing with scalpels when we're pumping. They're sledgehammers. So we deal in a high pressure environment, and often high pressure is forgiving of these nuances or trying to of these problems that exist. And it's really only the larger ones that show up sometimes. And then it would be remiss not to say excessive erosion on a particular perforation as well, right? We've seen some of that recently in the last few years of the service providers that look at those perforation diameters, that there's some percentage of those are more than we think that they should be or would hope, where the diameters are just drastically different. And then that's going to collapse our system as well, our design system.
Okay, I want to come back to this here in a little bit, another little twist here, but before we leave it, Dick commented about uniform hole size. Do you all agree that that is a significant factor? Is that almost a requirement for extreme limited entry to be successful, to have those uniform hole sizes or not?
It depends, but I would say if you're shooting more than one hole per cluster and it's not oriented, it's a simple answer that yes, it matters.
George, how important is uniform hole size?
Uniform hole size is very important for initial hydraulic isolation. I do kind of question how much it's going to affect the pressure after the sand or the proppant hits the perforations, because you're going to have some erosion right there. The amount of flow into a perforation carries the most proppant, probably sees the most erosion, because flow, it's going to depend on the formation, in that if you have a easily fracturable or high permeability streak, etc., that's going to preferentially attract and take the amount of flow, and also probably have the most erosion up to a point where you're not seeing interaction between the proppant and the steel at that point. So I'm going to leave my vote as kind of up in the air until we understand the erosion better.
Okay, Derek, we've got time for another poll question.
Yeah, we can do that here. Our second one, actually, we just covered pretty well of which of these techniques is the best to achieve optimum proppant coverage. We touched on extreme limited entry, consistent hole sizing. So maybe we'll just jump to the next one here. Let me launch it. Here you go.
What is your current fracture-driven interactions, FDI mitigation strategy? Do nothing, small preload on the parent wells, large preload on the parent wells, recharge the parent wells, refract the parent wells, far field diversion, or natural fracture identification. So, panel, while the audience is voting, what is your preferred fracture-driven interaction mitigation strategy? All things being equal. I know it's going to depend on the way the wells are aligned, but give us some overarching advice on how to select the most appropriate FDI mitigation strategy.
Let me start that one off. And basically, I've been working with Ali Donashi on this for quite some time, and a number of other folks as well. Basically here, know your geology, because what we're seeing, and we just finished an SPE summit on casing damage, causes of casing damage during fracturing. What what we're seeing is that geology has a huge influence on what we're doing. Bedding plane slip, fault activation, a number of things there. And also the proximity of wells. You can go through all of that. Recharge, depleted zones are one of the most important things to look and make sure you're not going to fracture into it. But what you absolutely need is put some monitoring pressure gauges in your offset wells so that you can see this thing approaching, and you can tell the difference between fracture shadowing and stress shadowing. You can see whether it's going to be a real high pressure connection or whether it's not. If it's not, you're not transferring a lot of liquids and proppant. You probably are not going to have a long duration in the connection. There's just a ton of things you can see, and I'll be talking about this later in an SPE program the first part of May. It's going to be a class there. But basically what you want to do is use every piece of data that you can find, analyze that, and this will help you understand this fracturing deal. But the most important thing, two things you can do: have gauges in your offset well and have control of your frac job to where you can change it on the fly. That'll make all the difference in the world. And we've already done this, seen this, demonstrated this.
Okay, how about the rest of you? FDI mitigation. All right, Dick.
I'll comment, buddy. I'll tell you, I voted refrac because I'm passionate about refracs, always have been. I think there's still some great opportunities there. I do think one thing that's often, and I agree with what George said, geology, overall lithology plays a key piece in this. And obviously, offset depletion always does too. But I think what's oftentimes overlooked, and I think this is what I like about extreme limited entry, is better near wellbore proppant distribution should help mitigate fracture-driven interaction. I think some of the places where we've seen higher fracture-driven interactions is where we've created some super clusters, and maybe you've got 10 clusters you were hoping to stimulate, but you're only stimulating through a couple of them. And I think that's something that's oftentimes not talked about.
Anyone else? Paul, what's your favorite FDI mitigation strategy?
From what I've seen, it's basin dependent. So I've done the most of them in the Bakken, not the Delaware. We're actually got a couple meetings next week, so I don't want to speak for the Delaware, but in the Bakken, I know it kind of depended on the vintage of the well, whether we thought it was something we could try and drive a production enhancement at the same time, or just simply limit the well from getting filled with its own sand as it got hit. When I say production enhancement, it's you're trying to make the infill well offset and the parent less bad or better than it might have otherwise been. But for us, we were doing 50,000 plus barrels just preloads with corrosion scale and surfactant laden fluid ahead of time, and then button it up downhole. And that seemed to be on the 8 or 10 of them we've done the last couple of years, prevented any inflow of sand from those offset hits. And obviously well spacing kind of makes that better or worse. But for us, that first goal was to simply not have to spend a couple $100,000 to go do a clean out on those parent wells. And then we, just continue to experiment on, well, if we're going to soak it, is there a surfactant that works? Should we let it soak? And so a lot of that data is where we were heading. But we didn't see the value on doing the refracs up there. None of our wells were that old to begin with. And we had just kind of looked at, hey, it's just the number of straws and how big is the milkshake, and there's only so much to get out of the ground. So you just have this balance of which wells you're going to get it spread out over the wells that over the oil that was available at whatever spacing. So yeah, again, trying to what we called fluid lock the wellbore and the formation. Roughly 50,000 barrels in a 2-mile lateral seemed to do the trick. I'm sure there's plenty of optimization to still do on that front. But we just do it as cheap as possible with produced water or fresh water. Frac was nearby, and we could just get the water for the lowest cost possible, make it happen efficiently. So
Well, you mentioned surfactants. Any advice on the types of surfactants or the application of the surfactants that might be beneficial?
Just high level, I think it's a lot of it has to do with just you need to get rock, you need to get core, and you need to do the testing. You know, I've done some work with the Liberty Oilfield Services guys, and I know they've done a lot of work with Dr. Schechter at A&M to come up with what the quickest, you know, couple week turnaround time is, just contact angles and interfacial tension, and getting those as a proxy for true ambient cell testing to get you the same, pointed to the same direction, you know, filter from 20 surfactants down to 2 or 3 that you may want to go test in the field. So I think there's value there, but you're talking small percentage value. You're not going to move the needle with it, is my current opinion. It doesn't mean it's not worth it. It just means you're not chasing a doubling or a 50% improvement. You're probably looking at, you know, early time responses and very quick payouts if you pick the right surfactant, but nothing that your management may care about in 2 or 3 years. You gotta be willing to fight the fight to put it in your AFE and justify it. So that's my experience, at least.
Okay, Derek, what's the latest results on our last poll question there?
Here you go.
Got a pretty good spread here. Do nothing, really? Okay, I wouldn't have necessarily guessed that.
I guess I was the only one that voted refrac, buddy.
Yeah, it doesn't look too good there, Dick. I know you are passionate about them. You had good success doing them. So I wouldn't rule them out. All right, good poll question.
Yeah, buddy, I guess just for that, I voted do nothing on that as well. Often because, let me make a general statement, right? With what we tend to do as an industry and the way and our well placements for economic field development, we cannot not hit the wells with the volumes that we're pumping. We're going to hit them. The engineering question is what I think George and Ali are working on. What's the effect of that? Do we damage the casing? That's bad. Things like that. But personally, I haven't supported these pumping into the wells to charge up. Paul's had some great experience with it. For me, I just don't think that we can divert. I mean, we know that we can't divert pre-perforated laterals charging up all the way to the toe because of the velocity change, right? So getting some extra charge up there in the heel section, I certainly think has value, right? So, but one of the strategies that I've seen we do is actually put more clusters, and assuming we can get diversion with however we do that, products or limited entry or design or rate or whatever it is, remember that by design, when we decide what a mass and a volume of fluid is, mass of proppant, and then we have a certain number of clusters at 100% efficiency, that's chopped up 5 times, right? And there's a length associated with that. Now we double our clusters, right? And we don't change those volumes, which is often not the case. Then those lengths are now half of what they are. And you can just keep going through those exercises. Now that presupposes that we can divert and all the other things that we've been talking about. But again, I'm a first principle guy. I'm a what we can control kind of guy. So spending money on recharges and things like that, there's probably some benefit to some portion of the well, but I know that we can't divert to the toe of a well given normal lengths, and we're not doing other things within these constraints. So the way the questions were framed, that's why I would have gone for a do nothing.
Yeah, and I guess, Lucas, I'll jump in there. I mean, Craig Cipolla and the Hess guys have written quite a few papers on microseismic depletion delineation, where they do see coverage for the whole well. I've done similar projects, and we actually can build over time, getting multiple step downs once we catch fluid at surface. We can kind of see ourselves build a frac gradient. And I think at an ATW that you and I were both at a couple of years ago, maybe the last one before COVID actually, you know, there's 3 or 4 people out there. I think it was Eagleford was covered. The Bakken was covered, and there was one other basin covered. Maybe it was the Devon guys in the Barnett. And they said, yeah, their preload was kind of a never ending, just they would keep preloading and getting step downs until they got, you know, 85% of the original frac gradient back. And then they knew they were anything that was open and not plugged by sand, that they could then go pump their refrac, and statistically they were having much better results. So I guess I just push back on it isn't futile. I used to hold that view, but slowly but surely over time, you do overcome some of that depletion difference. And there's several operators that have built, pretty good refrac programs back before COVID hit, under the principle that you could get that diversion of just fluid at low rate, slowly build pressure over time. So.
Yeah, Paul, no, fair enough. Yeah, I mean, I certainly disagree with that, right? I mean, energy, velocity, things like that are very real things, and microseismic is what microseismic is. But and pressure interpretation is what it is, right? So people that have success with it, I applaud them, support that, and I think they should continue doing that. More often, though, of what I see is maybe some young operators are new in a field, and because company is doing it across the fence, we're going to do it as well without quite understanding what it is the objective is. And all of that is a spend. All of that takes some value away from a new well. It could very well be worth it, depending on how one looks at that and does that. So certainly I don't disagree that people can do that. My experience with particularly working some of the formations in Canada, Cadman, where you can just go back to open hole horizontal fracturing, and the hardest rock you can do, and we can't get past a third of the heel, right? So there's just some very real limitations to it, but I certainly concede that there's very real data that supports someone's interpretation of that for sure.
Yeah, and I think just to be clear, I'm talking purely with fluid. Obviously, plug and perf in an open hole lateral versus an open hole lateral is a no-brainer for trying to actually get proppant over more initiation points. But I'm purely talking about preloading to get the well more or less balanced out, so that you are getting rid of the fluid or getting rid of any of the gas that might be trapped in the system and building a uniform pressure just with fluid, which velocity doesn't matter then. It's just time and patience.
Yeah, and money, right? Yeah.
Agreed.
Yeah.
All right. Good discussion.
One comment before we leave that.
Okay.
Is that Paul brought out a very interesting part here, and this may be basin specific. And on these frac driven interactions, you can have, they can help your wells, as they often do in the Bakken and the Haynesville, and used to do in the Barnett. We fracked one when I was working in the Barnett and upped the operator to the side of us. We upped his well 400,000 a day with our frac, and still got a decent well out of our well. But in certain areas like the Woodford and up into the Niobrara, that will kill your well getting hit by a refrac. So there's some geology differences here, but there's also some chemistry differences in what damages your production. And in many cases, you can track this back to your trapping water in these microcracks and natural fractures that now does not have the drive pressure in an older well to overcome the capillary blocking pressure and actually get them to flow. And we've had good luck with going in with small jobs, a little bit of acid to open some of these things up, and a surfactant, and gotten the production back in 2 weeks where it would have normally taken 2 years. But it is basin specific as to what's going to work.
Very good. Sort of a related topic, just out of curiosity, share with us what you think about maybe reconsidering simul-fracs and zipper fracs. Is there a place for those?
I think that's some of the best technology that is still in use. I mean, we were doing this in the Barnett years and years ago, and Dick can probably tell you more than I can on the EOG lease in Johnson County, I think it was the Fowler unit, that they had 5 frac fleets out there doing a 5-well stimulation. We had a well, pretty good well, 5-6 miles away, and every one of those 5 wells were double or triple the amount of production that we got out on this one little pad that we had. So I think, and after that, we went to zipper fracs. We saw a 20% uplift in production. So I still think that's one of the best things we can do.
What about it, Dick? You still a believer?
Oh, I for sure think there's some significant benefits in whether it's zipper or SIMO. I think the newest development with true simultaneous, pumping down multiple well bores, same time, same pad, there's a significant amount of cost efficiencies there. And in some areas where you've got location size that works, it probably makes a lot of sense. Most of the stuff I've seen says you really start seeing the efficiencies if you've got a multi-well pad with 4 or more wells. So I think that's a key piece in it. Obviously, in some basins, like up in the Northeast, the location size really kind of precludes it from being much of an effect up there.
And someplace in the Rockies, I would imagine that would be a difficult challenge as well. What about it, Paul? You a simul-frac, zipper frac guy?
Haven't got to the simul-fracking yet. Where we're in the Delaware now, I would say it's not kind of cookie cutter fracking. So I think simul-fracking, based on what I've seen and the guys I've talked to, guys and gals in different service companies, you really don't have, I guess it depends on the degree of what you call simul-fracking, but you really don't have a ton of control well to well to do step downs and do other diagnostics that we do every day to tweak our design on the fly. So you're kind of blurring a lot of lines there. And or you're rigging up 90% of 2 frac crews. And so you got to have way bigger location and a lot more people on location. And you are getting more footage treated per day, but you do lose some control. So I see why some people in certain basins where the fracking is pretty darn easy, it does make sense. It is more efficient. But in kind of the rock I'm working there right now, I don't actually get excited about having a 2-for-1 special. Now, zipper fracking, I think, is basin dependent as well. I think there's certain basins where there's 0 impact to production and it's highly, highly cost effective. There's probably some basins out there where people are convinced it does help. But I think even Dr. Sharma and the Shell guys put out a paper probably 8, 9, 10 years ago in the Eagle Ford and basically said that zipper fracking was hurting them, or it was helping them because it gave more time between stages for the leak off to occur. So they had less stress shadowing stage to stage in the same well. So, get back to the first principles of why it's helping. Is it truly complexity, or are we actually just letting some of the fluid and the net pressure leak off stage to stage while we're working on other wells? And is that what's driving it? I think it's kind of a pretty interesting geomechanics, fluid properties question that, again, there's not a silver bullet. It's basin to basin and needs to get thought through.
Lucas, any experience with either or both?
Well, both, certainly more zipper, but I couldn't fully support what Paul said more. It is a geomechanical issue. So it is basin specific, maybe. I mean, you cannot ignore the cost efficiencies, but certainly remember, we all have a mental model of what this is going to do, right? And it's different for everybody, right? A simul-frac or a zipper frac is going to create this. 10 people would draw it different if we asked them to of what's happening, right? So, but there's some very real things that we know. We know pressures and we know casing damage and things like that. So I do think it's more of a completion design problem as opposed to necessarily an automatic efficiency or mechanics solution, pipe mechanics, horsepower mechanics. So I have maybe, when we do it, the pressure bleed off, we'll call it leak off, right? It's probably not what we would traditionally think, the way we might have all been trained with what leak off is. We call it pressure dependent leak off, but it's not really a porosity perm solution. It's more of a geomechanical solution. And those can affect us from, as George said, fracture shadowing, fault shadowing, things like that. So when we do it, I do think there's some benefit to trying to stagger a little bit, maybe get some period ahead. Typically, I say 1,000 feet to 1,500 feet. Why? I don't know, 4, 5, 6 stages, right? That runs you about a day ahead, a day behind, sort of thing. But I do think that helps some with not having to pay for pressure loss or pay for fighting excess pressure that's been generated when we don't know, and if we don't know, that it helps us in production, right? It's just we're just paying to pump against what may not be helpful.
Okay. Let's jump into another topic, a little different subject. Do you gentlemen see a value in either core analysis based or image log, tracer log based identification of natural fractures prior to perforating and then fracking? In other words, how do you feel about engineered perforations? And is that useful? Is that an effective technique? What do you think? NFI, as we call it.
Dick, I think, or excuse me, Buddy, I think that could be advantageous if we can get accurate information relatively quickly. Many of these wells go down quick, and if you take much time for an image log or any other type of investigation tool to be useful, then it's going to be a difficult sell to get it to be used. However, if you do have that information, there's a couple of things that include both. Natural fractures are the best production mechanisms out of these type rocks, but secondarily, when you have a huge amount of natural fractures in an area, it may be an indicator that that's where you might have some formation movement and some pipe deformation, which could lead to some problems getting frac plugs down. So yes, it would be handy to have that data if we can get it quickly.
If you could get it quickly, would you target those areas for perforating, or would you perforate around them and let the fractures intersect?
It would depend on what one of those things that we have on a well and we rarely look at when we get into really quality, as we define it, discussions. Look at your mud log, look at your shows along there. Yes, the well is under control and there's not a lot showing, but you are releasing hydrocarbon as you drill through there. And when you see a lot of liquids coming in, and these can be your C2, C3, C4 liquids coming in, it means you have accumulations there of the higher carbon chain hydrocarbons that indicates you have some way to transport them there or to collect them there over time. And it's a good piece to look at, definitely to complete, but also I might want to use a little bit different type of cement in that area, or if those natural fractures are open, I'm going to avoid cement altogether and do it as an open hole completion. I've had experience in both of those things, and when you have natural fractures and you cement in there, you may never get them open again. Just depends on what you're completing. You got to know your geology.
About the rest of you, are you supporters of engineered perforating? Is there a better technique than what we've mentioned?
Well, buddy, I'm sorry, Paul, go ahead.
No, I was going to keep it simple. Is if you have the log resolution, I think you just need to not kid yourself, given that most people are shooting on the fly right now. So yeah, you might have 10, 15 clusters, 15 to 30 feet apart, whatever you're doing. But your probably accuracy in shooting is plus or minus 5 to 10 feet what you think it is. So just knowing the operational limitations of over engineering any design. And so how I look at it is really simple, is I try and lump like rock in the same stage. And if I think I have a fractured stage, that counts as like rock. I might do a very small footage stage that's focused on where we got a really high gas show or some other indication that we had fractures there, just because I know I'm more likely to treat it consistently. Even if that means I drop from 15 clusters to 5, that's kind of how we've treated them in the past and how we're doing it now. So,
how about you, Dick? What's your approach there to identifying and or targeting?
Let Lucas go.
Okay,
And I'll have a comment.
go ahead, Lucas.
Okay, I guess Dick's going to clean up whatever I say then, so that's good.
No, he's gonna summarize what everybody said.
Yeah, so I guess the way I would look at it, I think there's value in that. Not so much for engineered perforating because the operational mechanical limitations, as Paul described, are very real. So let's not be too clever with that. The reason I do see some value in that is entirely for what George says, that there are areas potentially of natural fractures that if they extend, they can give us some concern for some casing deformation, plug setting problems, some losses there. And then, you know, typically if you're fortunate enough to have seismic over the area, marrying that with coherence and amplitudes, then you can maybe get some little bit better signatures and some risk identifications. But it's important to say the reason I don't recommend that with perforating from a completion perspective is that there are in hydraulic fracturing, as we propagate fractures, there's only so many we can open. Natural fracture spacing has a relationship to bed thickness. Thin bed thickness, large bed thickness, not that it's 1-to-1, but there's some ratio there. So an overabundance of natural fractures, typically that we would expect to be closed in situ, simply you cannot open them all. Small features want to be large features. So an overabundance of image log fractures, that does not translate to that we can open those from a perforated system, a plug and perf system automatically. In fact, there will be some relationship that we will open that spacing on, right? Exxon research years ago told us the tightest you could probably get is 1-to-10 type of on opening these fractures. That may or may not be the case, but I certainly think that it's important to set the expectation. An abundance of natural fractures on an image log, even if we put perforations there, they would not open. They could not propagate simultaneously because of pressure, stress, competition, things like that.
Okay, Dick, bring all this together.
I think everybody's made some really good points. I do agree with Paul. I think in today's world, striving for efficiencies and stuff, engineered perforating makes it kind of difficult to do that, to focus on natural fractures or not focus on them, whatever your belief is. I think being able to group like rock, though, can have a significant effect. I know we've seen it with our diagnostics, and I've mentioned, poor near wellbore proppant placement. The easiest way to have poor plate, perf cluster efficiency is to have different kinds of rock. And so I think being able to group it can be very effective. I think one of the new products that we're just now introducing is something we've been doing for about over a year, but we're really now starting to ramp up, is where we're running proppant tracers in our cement spacer, with the idea of looking for high leak off areas as far as being a natural fracture identification tool. And we've had really good success, especially when comparing it with FMIs. It's something that we can, get out. I know mentioned the time aspect. It's something we can turn around very rapidly. So that's a great opportunity to get a feel for what your lithology heterogeneity is along the wellbore. And I think also marrying it with some of the rock characterization work. I know our sister division is working on a lot of that type of stuff. So places where we can integrate that to maybe get some of the true, a pseudo stress log along the well.
Okay, Derek, we have one last poll question.
We do. Let me grab it here.
Okay.
There you go.
All right, last poll question. What is the biggest opportunity in the U.S. unconventional plays? Refracs? Doesn't sound like that one's going to score too high today. unconventional EOR, still very low recovery factors, multilateral completions, or future recompletions? Where is the greatest opportunity in the U.S. unconventional market? Everybody vote. Okay,
Refracs, of course, right?
it's too late to lobby. You had your chance. Okay, got a few minutes left. Several topics we could cover, but we like to put a little personal spin on things as we get towards the end of these ProTech talks.
Hey, buddy, before we go too far, did you want to look at the results of this?
Okay, is it time? We give them enough time to do it?
Yeah, I don't know if there's any commentary from the panel we want to add. Otherwise, we can just look at the poll results.
Okay. Well, what is you gentlemen's opinions? How did you vote? Let's show the results, then tell us how you voted and why. Go ahead, Derek.
And I'll comment. Okay, go ahead.
All right, Dick, we know how you voted. Well, you're getting a little bit more support now.
I actually didn't vote Refracs because I didn't want to be the 1% again. But, you know, I think a big piece of this, and I did vote with the very low recovery factors. You know, we're still, and depending on what numbers, we're in the, you know, low teens, maybe better in some, especially if we're talking some of the oil basins around the country. So, you know, small changes, small increases in recovery factors is a huge, you know, number in terms of production. So I think there's still ways we can do a better job of that. And maybe it incorporates some of the unconventional EOR.
I agree. I voted there as well. How about the rest of you? How did you vote here?
Oh, it was kind of a trick question because doesn't unconventional EUR and low recovery factors kind of tie together?
Yeah, it could.
Yeah, so in my mind, you know, it could have gone one way or the other. It's just this idea of getting the proper well spacing, realizing there's a lot of oil in the ground, and whether it's surfactants or huff and puff or any other things that I think are going to be extremely basin specific. I think some basins have some obvious potential and other ones should obviously not be on the top of the priority list, but I think there's probably a lot to come in the rest of my career. So
George?
I'll agree with Paul on that. I'll agree with Paul on that one. And basically what you need to realize here is these wells have already been fractured, or already been drilled, already been fractured. You have this large amount of fracture to formation area, and we need to look at the chemistry of what's going on. But if you really look at the depletion factors, we're not depleting these things to hydrocarbons, we're depleting the pressure. It falls below the capillary blocking pressure. We need to look at gas injection, not so much just straight methane. The miscibility pressure on methane is a huge way up there, but the C2, C3s, C4s, you're going down to the 1800, down to about 1000 PSI miscibility factors. That can actually be some very good treatments on that, but we have to keep the fractures open. And we have been fracturing with conventional methods and just tuning them up to get to the unconventional. We're going to have to look a little further than that. We need to find ways of actually getting the micro mesh proppant back in there. And as Carl Montgomery pointed out in the last hydraulic fracturing conference, you have to wait about a year to really see the results of things like that happening. So patience again, and is this economic? You'll have to decide for that on your own, but I think that we're missing a bet not doing it.
There you go.
And buddy, I went with refrac actually.
Whoa, Dick won you over. All right.
Yeah, no, I do think there are just what we were doing as an industry. Let me just say a decade ago, 2011, 2012-ish, 13, 14, right? That where we have some extremely long stage spacing, some very wide space clusters. I was part of that, thinking that we needed wide space clusters. And I think given the proper candidates, because of what George says, these wells still produce, we haven't talked about it today, but they're still tight. We talked about linear flow, transient flow, pseudo steady state flow. These things matter in optimization, and the radius of investigation, like Lee would talk about, it's just not what you think it is in some of these legacy, I don't know if we want to, I don't know, first generation may not be the right terminology, but these older wells, large spacings, large clusters, I do think that some of this unfractured rock in between is therefore given other conditions. And the corollary would be, we have to find a way to do that economically or divert better or whatever the case would be for that. So I actually went with the refrac. I think there are a lot of opportunities there to add reserves to that. That refracs doesn't necessarily mean cheaper than new completions, right? I think you save money obviously on drilling, but refracs are not a low cost solution, but I do believe that they are a solution we should be looking at.
Okay, Paul, any updates on that?
No, like I said, I've been involved in a couple projects in the Bakken. I don't think we really have enough containment up there, but at the same time, I think you just have to design, do your design of experiment to really take in the time value of shut-in if you're talking EOR. And I think on refracs, again, it's probably very, very basin rock specific, vintage specific, original completion design specific on what those recipes are for, truly programmatic, economic return. And so, again, I just always shy away from silver bullets. I think Lucas said it the other day or earlier. You don't just want people looking over the fence saying, hey, it worked there, it should work here, just because EOR seems to have worked in the Eagle Ford sure doesn't guarantee it's going to work in the Bakken. And just making sure people are really thinking through why things might work in certain basins and what do they have that's the same, that's different, and just really honoring the engineering and the physics and the geology behind it, or geomechanics.
All right. Okay, got just a few minutes left. We want to get some advice from you gentlemen, and also ask a question about your background. As an admired technocrat in the industry, quickly share with us the most inspirational leader in your career and why. Dick, you're going to have to come up with another one. You've already done one. So who is the most inspirational leader in your career and why did he inspire you? George, somebody in Amoco?
Okay, yes, it was George Holman, who passed a couple of years ago now, but I was the youngest one in my group in Amoco Research for 15 years, but George was a former area engineer in Andrews, Texas. And basically, when I came into research, he says, you'll always have a job. You're like a plumber. You're going to need a plumber from the time you build a house till the time you tear it down. And that's what completion guys are, is they're plumbers. And very, very good analysis there. And he said, stick to if you want a job for the longest time, stick as close as you can to the producing side of the margin there and go from there. If you can improve that, you'll always have a job.
Cool. All right. Well, the rest of you. Paul, who's inspired you the most?
I would say I got challenged the most. I was on a team at Shell, and we had a lead called, guy's name is Travis Purvis, and he made the comment that you don't know where the line is until you cross it. And so we started just challenging everything we were doing. If this worked, let's do more of this. If that worked, let's do more of that. I think I've applied it a lot to even the limited entry now, and even surfactants and fluid chemistry. It's kind of this justify it or drop it. If that means you got to go 3x the concentration, do it. If it means you need to break a few things, do it. As long as you don't hurt anybody in the process. and just that idea of what's next. And, you know, you don't know where the line is until you cross it sometimes. So
I'd say your career has demonstrated that, as a matter of fact. Lucas, how about it? Who inspired you? Somebody at Conoco?
Well, you know, buddy, the way I would answer that is, you know, one, I think could always be a moving target, right? But I would say that I've been fortunate to work with a lot of very intelligent people. There's a lot of smart people to work with. But I would say actually that Bruce Meyer and George King, and not just because George is here.
Oh, George.
Yeah, because what I learned from them is, as a young engineer, you have ambition, you have whatever it is, but it's sort of chaos, really, right? And you have an education, but you don't really know how to think. You don't know how to understand what's important. You don't know how to approach research. You don't know how to approach projects, and you don't know how to communicate, right? Some of the most important things that I learned was how to communicate what it is that you've done. And I think it takes certain type of people to train to not that George sat there with me and I sat in his office and that he trained me, but he showed me what it takes to be successful with that, and how you can take very complex ideas, develop very complex projects and pilots, and have a way to keep that chaos and communicate the results of that. So for that, I'm very thankful to both of them. And Buddy Woodruff as well. I learned the same from Buddy, right?
Oh, that's nice of you. I appreciate that. Well, George, you'd be on my short list too, I'll have to admit. Dick, how about it?
Well, Buddy, I can't pick you because that would be inappropriate.
Yeah, that would be a little homerism there.
So as a second choice, I would have to say one of my supervisors at Union Pacific, Bob Whitman. And I think the biggest thing he kind of mentored all the engineers on is just apply, and it's kind of a common theme we've heard several times here, but pushing the envelope, think outside of the box, fail forward faster. The idea being we don't know the limits until you've gotten out and gone too far. And I think that a lot of what we've seen advances over the last 20 years, 30 years happened because of that. I know when we get to slick water fracking and how that actually started, I mean, it was not something that was truly planned. It was a lot of work that was done, but we were really cutting costs and made the decision we're going to try to flow a well back after we put very little profit on it. And so I think those types of things, and I encourage younger engineers, both on my team and in the industry, you know, look for new ways to do things. You know, we apply that education we've spent a lot of money getting, and look for new ways to do a better job of getting the hydrocarbons out of the ground.
Very good. Okay, let me fill you in on who went where before we leave here. Paul has already given it away. He was a Longhorn, and his favorite college hangout was the Posse East. So that's a little bit of his background. George King and Lucas are probably two that you might not have been able to figure out just right off the top. Dick was another one who was a Longhorn. And what was the name of that beer garden there that was your hangout?
Schultz's Beer Garden.
Schultz's Beer Garden, the oldest continuous existing business in Texas. Well, George King, if you know him, you probably would have figured this out already, but his favorite hangout in Oklahoma, he went to Oklahoma State and the University of Tulsa to get his various degrees there, one in chemistry and the others in engineering. His favorite hangout in college was any garage with sports cars. If you know George, he's got a passion for sports cars. He's owned half a dozen Mustangs or more in his lifetime. Would never sell me one of his Cobras. Still hold that against you, but anyway, that was his passion. And Lucas, his favorite hangout was in the campus petroleum lounge at A&M, playing 42. The correct answer, Lucas, was supposed to be the Dixie chicken in your case, but obviously you went a little different direction than so many Aggies.
I did. Hey, buddy, I guess I would like to say, I didn't know they had a school in Austin.
Okay, here we go.
Yeah.
The gauntlet has been dropped.
Hey, all I know is two
Go
of
ahead.
the four premier panelists came from that school. So we outvote you.
No, I know. I'm just kidding on that. There's actually a program with A&M and Texas that when you graduate from Texas, you can transfer in as a sophomore. And we welcome those transfers. We're very happy to do so.
Yeah, if they didn't come in, you wouldn't meet anybody from the rest of the world in that little bubble of Bryan College Station.
Yeah, we love our bubble. We love our bubble.
All right, one last question. And I think George and I talked about this a little bit before we began. If you could personally advise the new administration in Washington the best way to balance the need for increased fossil fuel production, transitioning to renewables, and safeguarding the environment, what advice would you give them? So George, come on, you've already thought about it. So we'll start with you.
Okay. And I've talked to a lot of environmentalists over the years, and what they don't understand could fill libraries. Basically, the total U.S. energy supply is 80% fossil fuels. Still is that, and it's been unchanged. It fluctuates up, a little less coal, a little bit more gas for many, many decades now. Now, the alternate energies, there's some things they need to overcome. Every one of them has its problems, but Stephen Chu in the Obama administration actually, and he was an energy guy, he said the biggest problems that alternate energy faces is it cannot store energy efficiently. And basically, this is an advantage of the fossil fuels because of the energy density and the energy storage ability. And if we would look at problems like methane leaks, well, about 80 to 90% of your methane leaks come from about 5% of the facilities, and they're typically a very poor gas processing facility, compressors, things like this, including coal mines that have a lot of methane leakage. Those are the things you need to attack first. The wells haven't been that much of an issue. Transmission lines are terrible. If you look at the cities with the worst methane leakage problems, and the Environmental Defense Fund did this a couple of years ago. I got to see that report. The worst city was Boston, and it's from leaky infrastructure carrying natural gas. So there's some really strange things out there. You need to look deeper into why it causes this. But the underlying ultimate driver behind every bit of the climate change, and it definitely is climate change, is the population increase of the world, which from the time I was born in 1949, it was 2 billion people. Now it's over 7 going towards 9. And the standard of living has gone up. Energy usage has gone up. What have we done about efficiencies, about, just conservation? But as you move through this, yes, we can all convert to electric driven cars, but hey, 80% of your electricity still comes from fossil fuels, and you got to recharge them somehow. Just get people to think. That's where I'll leave it.
All right. How about some advice from your other gentleman?
I can't really add anything to. I agree with George. It's we're gonna have a mix of energy from this point on, and is it going to change dramatically because of the current administration? There's going to be some subtle changes, but it's not like overnight's going to happen. And I think if you use what we just went through a month ago here in Texas with the storm, and they had I saw something on the news last night that said, oh, everybody says, well, yeah, we need to have, do maintenance on all of these plants. We need to do all this. But then the next question is, you're going to be willing to pay for it? And it was like 90% said, no, we're not going to pay for it. Well, the reality is that's the problem is if you go to 100% renewables, no one's going to be willing to go to that thing because it's going to be too expensive. We're still the least, most cost-effective energy source in the world.
Paul, any advice for these folks?
I think it's a good combination of comments that have been made, but there's a group called the Manhattan Institute that has written a paper. I think it's about 25, 30 pages long, and it's called An Exercise in Magical Thinking. And it gets into just some of the physics-based limitations on the renewable grid. And I think it's just a pretty darn informative short read to kind of get your facts straight. And then just being very well aware of, you're starting to hear more and more people come out about, hey, renewables require a ton of mining. So if anything, the push on renewables may create an absolute boon for anybody involved in, kind of your classic mining industries, rare earth metals. I think there's one operating mine in the United States right now, right? So it's just kind of an interesting give or take, but eventually it'll show up in the prices and they'll be totally fine with natural gas again. That's my prediction.
There you go. And George, I forgot to ask you, being an Oklahoma State grad, did you not hang out at Eskimo Joe's?
Now, buddy, I gave everybody hints by holding up my Eskimo Joe's
I
cup
didn't notice. My bad.
several times, taking a drink here.
My bad.
And actually, no, I didn't, because Eskimo Joe's was built after I was there, not before.
Oh.
So I predate Eskimo Joe's in Stillwater, but my kids went to OSU and I've got plenty of Eskimo Joe cups.
There you go. Well, thanks, folks. We've gone a little bit over time, but it's been a stimulating conversation. And we very much appreciate the time that you gentlemen have spent to share your knowledge and experience with us. I think we've all garnered a great deal of good advice. I think we're moving up that ladder from information to knowledge to wisdom. And I think gentlemen like yourselves and being around you guys can help speed up the process as we work our way up that ladder. So thank you for all the attendees. We appreciate your time. Derek, I'll turn it over to you for the finishing comments here.
That's about it. That'll wrap us up. Thank you everybody for joining. Thanks to our panel. Awesome discussion. So we'll get this video wrapped up and recorded and posted online with the rest of them here soon. I put that link in the chat. So thanks again. We'll keep an eye out for the next ProTech Talk via the email invite or LinkedIn posts. So everyone have a great rest of your day and weekend, and we'll see you next time. Thanks.
And if you panelists, since you don't have a team to root for in the Final Four, I would suggest Baylor would be a good choice, where my daughter graduated. So go Bears.
Go Bears.
Got them Longhorns stealing your Texas Tech coach, buddy. What's your thoughts on that?
I'm sorry, I've got another meeting I've got to go to here.
Yeah. Go Horns.
You guys
Go
have a
Horns.
good week.
Thanks for having us, guys. Talk to you later.
Bye, everybody. Thank you.
Thank you.
Thanks, everybody. Lucas,
Thank
Paul,
you all very
George,
much.
really enjoyed it.
Happy Easter. Take care.
Yeah, have a great Easter, folks.
Happy Easter.